Welcome everybody, welcome to Ignite here in Auckland at Sky City, and for coming along to my session this afternoon on Always On in SQL Server 2016. For those of you who don't know me, my name is Warwick Rudd. I'm a Microsoft Certified Master, Data Platform MVP, formerly known as a SQL Server MVP, and the Principal Consultant with SQL Masters Consulting. My contact details are up on the screen, so feel free to reach out to me, ask me any questions via these contacts for anything from today's session, or if you've just got any other questions at all. So what are we here to talk about? So this is the abstract of today's session. Now I'm not going to read through this abstract. Hopefully you've all had a chance to read through this abstract, and that's why you're in this session. Okay? But what we're hoping to take away from this. So I've got 3 goals for you. Hopefully that I'll take you on that journey from Generation 1 through to Generation 3 of Always On availability groups, allowing you to take away the knowledge of what 2016 brings to the table and how that can impact your environment, and for you to be able to go back to your organisations and lead discussions around what's available and how that can be implemented in your environment. Okay, lucky we're here to talk about availability. Okay, so we've got some terms and concepts up on the screen. Hopefully some of you, or most of you, will know what these are. Now there are some additional ones, wrong one. There are some additional ones which are often thrown in and talked about in the same context, okay? The second lot that I've brought up, a majority of the time, are there for disaster recoverability. Today's session, we're just talking about high availability, even though what we're going to cover can actually be used for disaster recoverability as well. Okay, but you just need to know the difference between the terms, what they actually mean, and whether it's high availability or disaster recoverability, because they are a different topic. Before we dive in, how many people here are already using availability groups? Okay. How many people are thinking about using availability groups? Okay, so for those of you who aren't, what's stopping you using availability groups at the moment? What's stopping you from making that step to implementing them in your environment? Time? Sorry, what was that? Licensing? Okay, that's a good question. So, with the release of SQL Server 2012, we got the introduction of Always On availability groups. Now the majority, or the big technology that we needed to have in place, Windows Server failover clustering. How many people have been using failover clustered instances? Okay, so this comes under the whole banner of Always On, because Always On covers failover clustered instances, Always On availability groups. Always On is your marketing term, okay? But we need to understand the difference between them. But what did it bring to the table? So we could create our availability group. We could have 5 replicas, 1 primary, 4 secondaries. We could have 2 synchronous partners, 2 failover targets, readable secondaries, and the part that I think that makes availability groups probably the best configuration for your HA and DR is the listener. Because from your application point of view, your application people no longer need to know what server they're connected to, where that server is located. As long as it has the ability to poll and reconnect after it loses a connection, which is what will happen in a failover, it's able to reconnect and the application has no idea where its underlying data is at. 2014. We got some enhancements. Okay, so we basically doubled the number of secondary replicas that we could use. So we went from 4 to 8. We increased our synchronous partners from 2 to 3. And we got Azure integration, allowing us to go to a hybrid environment. So 2016, which was only released earlier this year, we have a huge number of enhancements or new features into the environment. Okay, this is what we'll be covering over the next course of the session this afternoon. So let's dive in. First off, dependencies. no longer dependent on 32-bit. .NET Framework 3.5, we don't need to use it. Alan Hurt from SQL HA has a great blog. The link is up there. Go and have a read of his interpretation and telling you about that .NET 3.5 is dead from a SQL Server point of view. Okay. Standard edition support goes with the statement earlier about licensing. Okay, we are no longer an enterprise level feature. It also means that database mirroring, which has been marked deprecated, we can finally get rid of it. Okay, because the reason why it's been hanging around, there was no direct relationship or replacement for database mirroring. Availability groups now in 2016, because we've got standard edition support, gives us the same as database mirroring. Domain independent availability groups. With the release of Windows Server 2016, last week I think it was, gives us the ability to create multi-domain and also no domain Windows Server failover clusters. The requirement for building a Windows Server failover cluster was a domain. Because that's now gone, we've now got a direct replacement for database mirroring. So as we started with 2012, multi-subnet support came available. Prior to that, if I wanted to create a multi-site Windows Server failover cluster, what did I have to do? Stretch your VLAN. That was easy for me. I raised a request, sent it off to my network guys. Stretch your VLAN, please. Grumble, grumble, grumble. Wait however long, it comes back. I then can create my multi-site cluster. 2012 changed that. They could then have multiple subnets. As we spoke, multi-domain support. Also, I'm in the way, sorry. No domain support. Now we do have a caveat. Oh, we skipped ahead. With our full trust and no trusts. So with your multi-domains, okay, it can either be trusted or non-trusted. It's supported to create that Windows Server failover cluster. But we do have to be running Windows Server 2016 to be able to create that. Standard edition support. Our feature's up on the screen. Looks very similar to database mirroring, doesn't it? Yeah? One caveat difference. Asynchronous or synchronous data transfer. Okay? Standard edition, database mirroring. You have to have synchronous. You don't get asynchronous until you go enterprise edition. Benefits that availability groups in standard edition give you over database mirroring. The performance improvement that we'll talk about later on in the session. Okay? So if you're still running database mirroring, okay, there's no reason for you to push for 2016. You'll get improved performance, improved failover ability, improved scalability. The other thing is database mirroring, because it's been marked as deprecated, it hasn't had any love from the product team in years. All of the work is being done on availability groups. Okay? So let's have a look at our first demo. So in my demo environment, I'm just connected to my server. Oh, it's not a very good line. SMCWG SQL 01. We're a work group, but we're also a cluster. Okay? There are some caveats that you need to put in place in creating your non-domain or work group cluster. If we have a look at our server properties, all of the servers that are in the cluster have to have a DNS suffix. It will not work. Okay? We don't have to have access to a domain, but we do have to have access to DNS to make this work. Once we've got that, now this is a change from CTP. Now I had to actually rebuild my environment this week for you because with the release of 2016 coming actually available, this was built on CTP5 and things have changed slightly between the CTP and actually RTM. So we can actually now connect to our cluster on our local workgroup. In CTP, you couldn't do this. What was one of the requirements from a clustering point of view to be able to, using Cluster Manager, to start it up and connect to a cluster? Anybody know? Had to have a domain account, had to be able to connect to the domain. We're not in a domain. That's now changed to allow us to come in and see our cluster and manage it. So if we just have a look at the properties, just like a normal cluster, we can manage it. We can't create it in Cluster Manager. For that, we have to use PowerShell. Now, I said before that we had to have the DNS suffix in place. On all of the cluster nodes, we also have to go and run this statement here, which goes and makes a change in your registry. Once that's in play, we can then run the second one. Okay? One line in PowerShell to create your cluster. Give it your cluster name, your cluster nodes. You must give it the administrative access point of DNS. And then I've given it a static IP address. In PowerShell, we can then go and have a look. So if we run the cluster resources, I need to run it as administrator to have access to the PowerShell commandlets. Okay, so we can see all of the same details that we're seeing in Cluster Manager via PowerShell. So if you aren't using PowerShell, you need to start and learn PowerShell. Okay. From a SQL Server point of view, if we come into Management Studio, we can have a look at our dashboard. It gives us all of the same information. What we have to do to configure this from a SQL point of view to create our availability group is use certificates, just like we did with database mirroring. So who in the room is using or has set up or configured database mirroring in a workgroup environment? Okay, so the setup is exactly the same. You've got to create your endpoints on both servers. You've got to have local accounts on both servers, create certificates, put them over onto the other servers, grant them permission so the connectivity can work. That's how this happens here. So there's some manual steps that you've got to go through to configure it. Once it's configured, it does exactly the same thing. So just to show, if we do a connection, okay, so we can see that we're currently connected to Workgroup 1 SQL 01. If I connect to my secondary replica, perform a failover, everything works the same. The way that you manage it, there we go, we've failed over already. Run our statement again. We're now running on SQL 02. So I've just very quickly gone through, had a look and shown we're working in a workgroup cluster with an availability group. We've been able to connect, fail over, reconnect. So let's have a look at standard edition. So we'll just change servers. There we go. So I've got two instances of standard edition on here, and just so that you are seeing that we are running standard edition. Okay, so Microsoft SQL Server Standard Edition. the availability groups, they've made changes depending on the SKU that you're running on what features are available to you. So if we have a look at the properties of our availability group in Standard Edition, all of the same connections or same settings. If we have a look here, basic availability group, we can't change it. It's on automatically by the SKU that we're running. Okay, by that SKU, that's how it's determining what we can and can't do. So as we saw on the slide, there were some caveats on what we were able to have in place. Okay, so I can change the availability mode. Why are you not? Oh, because you're the secondary. We'll fix that. Okay, let's go back in and have a look at our properties again. So we can see I can change the synchronous and asynchronous, no problems at all. The automatic and manual failover will be dependent on what type of synchronous partner we're using. Readable secondaries, we don't have an option, okay? To change the readable secondary. If we were to go and try and add another database to the availability group, we can't, okay, because we're restricted to one database, just like in mirroring. If we went to try and add an additional replica, connect to our secondary, we can't add another replica. The SKU is preventing us from that. But it's a direct replacement for database mirroring. So let's go back to our slides. In your current environments, so who's running SQL Server 2012? 2014? Okay. If you had a 3-node cluster, and this is a traditional setup, normally would be a DR setup. So our 2 in primary data center for HA, 1 in our secondary data center. But it would look like this, where you've got your 3 synchronous targets, your 2 automatic failover targets. If we have a problem with Brisbane 1, we automatically fail over to Brisbane 2. We've still got our synchronous transfer from Brisbane 2 to Brisbane 3. However, we've only got the ability for a manual failover. So this is where your monitoring comes into play. One, that it's told you that you've had an issue and you've failed over. And now that you're running on this one, that you've now got another issue to notify you so that you can perform that manual failover. That affects your SLAs and your uptime, okay? Because however long it takes for you to be notified that you've had an issue on Brisbane 2 to come in and actually manually fail it over, it's all dependent on what your SLAs are and how much over the 12 months your uptime is required. So this is where 2016 changes that, where we've gone from the 2 auto failover or the 2 failover targets to the 3 failover targets, matching up now with your synchronous targets. So in the same scenario, we have an issue with Brisbane 1, we come over, we've still got auto failover from Brisbane 2 to Brisbane 3. Okay, so then if we have a failure, it will automatically fail over. We stay up and running, we keep our SLAs. Continuing from a failover point of view, how many people in here are not or have not been able to go to availability groups because you've got applications that use distributed transactions? Okay, we've got a few. 2016 alleviates that partially for you. We've now got DTC support. As we can see up in the top corner there, we do have some caveats. And those caveats are that cross-database, same instance is not supported. Cross-database, cross-instance is supported. So if you've got a database in 2 separate instances, and you've got distributed transactions going between them, that is supported with availability groups. Excuse me. Is that going to allow you to possibly move towards availability groups? Bearing in mind, the only technology available that gives you true support for distributed transactions from a HA or DR point of view is failover clustered instances. Database mirroring doesn't give you this. Log shipping doesn't give you this. Okay? You might be using it, but it doesn't give you 100% support. The other one, from a failover rules, in 2012 and 2014, availability groups are based at the database level. The failover health is set at the instance level. So you have to have a problem at the instance level in 2012 or 2014 for it to fail over. With the release of 2016, we now get database level health. Now it's something that you have to manually configure, okay? But what it means is that you can go in, once you've got it configured, if you've got an availability group with 5 databases in it, if one of those databases has a problem, it triggers a failover of the entire availability group, which is what you're wanting. Read-only replicas. So 2012, or I shouldn't say 2012, but availability groups gave us this ability. It means that we were able to shift our workload, use resources on our secondaries so that we weren't impacting what's happening on our primary site or on our production database server. In 2012 and 2014, you do have the potential for a performance bottleneck. And that's because every time your application hits the listener and it says, I want to read the readable secondary, it sends all of those transactions. In this situation, it would send all of those transactions to Brisbane 2. Now, if you've got a very heavy environment with a lot of reporting happening, then that's a lot of transactions which are all going to Brisbane 2. So you've got the potential of a performance bottleneck with all of those transactions hitting that server. 2016 changes that with a round-robin approach. To change it, it's very simple. When we create our read-only routing list, in 2012 or 2014, you've got read-only routing list equals, and you give your 3 servers. 2016, to get the round-robin approach, we add the inside parentheses. So we group it, and we say, we want these ones here to round-robin, anything else is what they will fail over to if both of those are not available. And it would look a bit like this. Now in that situation, you might find yourself back into that performance bottleneck because you've now got everything going over to this server here. The likelihood of it is, if we're going to this server here, we're in a disaster recovery event because we've probably lost the whole site. Now this is a new feature which has come out, direct seeding. So when we create an availability group, whether you do it manually via T-SQL or whether you use the wizard, what it's going and doing, the database that you select, we're taking a full database backup, copying it over to the server or to the replicas, doing a restore, taking a transaction log backup, copying it over, doing a restore until they're both in sync and we're then able to join them. Direct seeding changes that. It eliminates that need to do that backup and restore process. It doesn't break the log chain backup, but your transaction log size, you need to be wary of it. So depending on the size of the database that you're adding to an availability group, the distance that you're moving it to, the size of the pipe that you've got between your replicas, what sort of transactions you're happening on your primary replica. Because during the phase where it starts and it starts to seed over onto your replica, all of those new transactions which are coming in, they have to sit and wait in the transaction log until it catches up and it's fully synced. Okay? So you've got to be wary about that. Bearing in mind, you're limited to, for one transaction log, 2 terabytes. So it does depend on what your environment is like. Also, when it's doing that, by default, it doesn't use compression. You can enable it. There is a trace flag that allows you to enable compression for during the seeding process. But if you just use it by default, it won't enable it. How do we do this? By adding seeding mode equals automatic into the creation of our availability group. So let's have a look at our second demo for this afternoon. So if we were to run this statement back in your environment, the results that we see here, this is a 2014 setup, 2012, 2014 setup, it doesn't matter. But what it's telling us, that when our replica, our primary replica is APAC SQL 01, then we're going to route to SQL 02, then SQL 03. Notice your routing priority, 1, 2. So it's always going to hit, as long as SQL 02 is available, it's always going to hit SQL 02. And this is where I was saying that you've got the potential for that performance bottleneck with all of those transactions hitting that server. Now I've just got a little PowerShell script, so I'll just kick this off. Oops, wrong location. Now, okay, it's a bit blurry for you, but what we're seeing here, so my PowerShell script, all it's doing is connecting to the availability group listener and running select add@server server name. So what is my server that I'm currently connected to? So this is showing us that we're hitting SQL 01. If we have a look at in Management Studio, we can see that SQL 01 is a secondary. Okay, if we connect to, I'm going to have it as a guess, SQL 02 is our current primary. SQL 02 is our current primary. So we're going to hit, first off, SQL 01, which is what it's doing. To change that, we just need to go and change the routing list on all of our servers. So we've just got to cycle through. So because 02 is our current primary, we executed on 03. Now depending on your environment, on how long this will take, you'll need to cycle through 2, 3, 4, 5, however many replicas you've got in your environment. But we can see the parentheses around the two servers. Okay, so that's telling us they're the group that we want to have together for our round robin approach. Last one. Okay. So if we run the same statement again, we can see that we're alternating between servers. Okay? So by changing that routing list, running the same command, all we're doing is alternating between, therefore getting better performance because you're going to alternate and use the resources on those replicas. Just be careful of connection pooling. Okay, I got caught when I was putting this together. Everything was just going to the one server. I'd then stop, wait for a while, run, it'd change. Okay, so just be careful of your connection pooling. from our database level failover, if we have a look at our properties. Now, when I already created this availability group, I selected it, okay? Database level health detection. If you don't have it off, that's fine. It will still function in the 2012-2014 way of functioning. By turning it on, having that a problem with a particular database will cause that failover. So all I'm going to do is run a statement which is going to connect to, yeah, that's okay. Connect to our, oh no, I need to swap it. Just going to swap it over because what I'm going to do to simulate and show this, I'm going to simulate a disk issue. So I've just got a PowerShell script which I'm just going to rip a disk out. Okay, but the PowerShell script is specific to node 1. So I'm just failing back over to node 1 so that we do get that working. So what I'm going to do is we're just running a simple statement which is simulating a workload. We're connecting to our availability group. We're going to create a table. We're just going to insert some rows into that table. While that's executing, we'll just come over to PowerShell. I'm just ripping that disk out from underneath us, okay? So we've now ripped that out. Come back to Management Studio. We've completed with errors, as we'd expect, okay? Because the disk that my data and log files were residing on just got ripped out from underneath us. Could happen, couldn't it? You could lose a disk, therefore your database goes offline, and your transactions can no longer write to the transaction log file. If we have a look at our availability group, node 1 is now our secondary. Okay, it's automatically failed over to node 2. Oops. If we connect to our availability group, which is what your application would look at doing, we can see that we're now connected to node 2 and that we had 13 insert statements happen before we lost our disk. So that's where you'd have your monitoring in place. You'd go and fix the problem. In this case, it's relatively simple. I'm just going to turn the disk back on. It's now fixed. Just to make sure that everything is all running fine, we'll just do a restart of SQL Server, making sure that, and yes, making sure that we haven't got any leftover issues from having that disk taken away, allows our database to start back up, go through the check DB phase, making sure everything is all okay, which you would look at doing. Perform a fail back, and that comes up and online. Okay. More often than not, people will have a preferred node that they want. Are you in sync yet? Synchronized, thank you. You'll have a preferred node in your cluster that you would want things to run on, even though technically there's no reason why you can't unless you've spec'd your servers differently. So we're just failing back to node 1, making sure that everything is all okay. And our application, we reconnect, and it continues on its merry way. That'll then complete and just show us that it's completed. So what did we, I think we had 13 or 14 transactions before. We've now continued and we've got 24 transactions. So from our direct seeding, so this is just a normal script that you would have to go and create your availability group. Now I've just zoomed in. The only difference So we've added the seeding mode. That's the only change that we need to add to our availability group creation script to utilise direct seeding. So if we execute that on our primary server, we then have a look at our availability groups. Okay, we've created our availability group with our replicas going for 1, 2 and 3. We've got our availability group database. I haven't created a listener in this case. Okay, we can create a listener at any point in time. If we then go over to node 2 and we expand it, it hasn't been created there. Okay, we've only just done the first part of it. Now, normally what you would do after we've done this step is where you would take your backups, copy them across, do your restores onto your secondaries. You would then join those to the availability group and then enable the HA feature. For us, we go to the secondary. Two lines for our automatic seeding. Okay, so we're going to join our availability group or our replica to the availability group. That hasn't changed. The second line, we're granting the availability group create any database permissions. So by doing that, so if we run that, we then do a refresh. We can see our availability group. If we do a refresh of, see we're in a restoring. Let me just, a little bit more real estate. So our database is in a restoring state. So what that's done is we've granted the availability group the permissions to create the database. So it's gone and created the empty database shell, and it's then started seeding all of the transactions across the wire from our primary to our secondary. So if I do a refresh, it's now synchronized. Okay, this is a very small database because it's just my demo environment. And then we do exactly the same on our node 3. And it works through. Okay? Be very careful how you use this, on where you're going to be going to. If you're in a hybrid environment and you're using a 1 terabyte database, the likelihood is you're not going to want to use something like this to direct seed from your on-premise up to Azure. Okay, the time that it will take, your transaction log will probably blow. Okay, so you will probably need to do the old way of doing things, backup, restore, backup, restore, backup, restore, until you get close enough to bring it in sync. Just because of the time it takes to get up there. So, all right. So what we've just been through, we've had a look at the database level failover, the round robin readable secondaries, and the direct seeding on how they can assist you in your environment. So let's go back to the slides. Some further support that we get with 2016. So SSIS DB support. Now, since SSIS DB became available, we've been able to add it as a availability database. However, there's manual steps that you need to do. When you, for the package to run after you've done a failover, okay, because depending on any of the sensitive data that is saved inside your package, it's encrypted via the master key. That master key needs to be available on all of your replicas. You need to have agent jobs created on your replicas to go and work out, have I had a failover? Do I start to now use this package? Okay, you have to do that manually. 2016 changes that. When you add the database to the availability group, it asks you for your master key password. So then it goes and creates the appropriate security setup on all of your replicas. It goes and creates the agent jobs for you on all of the replicas so that when you have a failover, your job just works. Okay, so it just makes it simple for you. Online operations. There's been some enhancements too, which aren't specific to availability groups, just generally inside of SQL Server 2016. So we can run the truncate table statement at the petition level, which means that we don't have to take the entire table offline, which means that we meet our HA requirements, we stay up and online, we meet our SLAs. There's also been enhancements to the alter table statement, so we can now alter columns and stay online. Therefore, the table doesn't go offline, we don't miss breaching our SLAs. From a security point of view, group managed service accounts. Has anybody heard of them? 1, 2, 3, 4. Okay. Are you using them? No. Okay. How many people in here have an environment where you are required by legislation or anything like that from an auditing point of view to change the passwords of your service accounts on a regular basis? Yeah? What's your biggest pain point? Anybody? Yep. But to go and change the service account password, the biggest pain point is you have to restart your instance for it to take effect. That means that you have to have a failover, which means that you've got an outage. Group managed service accounts change that. What they allow, they've been around, so I think they first came about with managed service accounts, which is a one-to-one relationship. Now got group managed service accounts, okay? That allows us to have one account for a group of servers. The benefits are with 2016 specifically for availability groups. They are now fully supported. They don't cause a failover, right? It also relies on your password policy of Active Directory. That might be set every 30 days, every 90 days, okay? It will automatically go and change that. It doesn't cause a restart of that instance, therefore doesn't cause a failover, therefore doesn't breach your SLAs. Benefits of group managed service accounts. I never ever know what the password is for that service account. I can't actually go and, even if I did find out what the password is, I can't use that account, go and log onto a server and use and impersonate that account to do whatever. Have a look at group managed service accounts for your environments, not just for availability groups, but it makes your life a whole lot easier as a DBA. You no longer have to remember or have a password repository for your service accounts. It's just done behind the scenes. TDE support. TDE-enabled databases are supported and have been supported in availability groups since day dot. The problem was all of the additional work that you need to go and do to ensure that you could, one, restore the database over onto all of your replicas. So depending on what type of security you were using, whether you were using symmetric keys, asymmetric keys, certificates, however you were doing it, if you're up in Azure, storing the keys in Azure Key Vault, you've got to go and enable those encryption processes on all of your replicas before you can go and restore the database. You also can't restore or add the database using the wizard. 2016, that's changed. You can now add it via the wizard. It will ask you for the details and it will go and do those, set those up for you on all of your replicas, making your job a whole lot easier. So the performance. 2012 and 2014, the biggest performance problem that we have is the transport layer. And that means sending the data from our primary across to our secondary. So going from our log capture to our log receive, that's our data transport. We then have our redo phase. The problem is, at the moment, with 2012 and 2014, so the transport layer is sending that data across. It's using, it is encrypted, but it's in a serialized fashion. The redo phase is also in a serialized fashion. So with the introduction of PCI Express, Fusion cards, SSDs, we could write more transactions to our primary. Our secondary can't keep up, okay, because we're having to send it across. That redo phase isn't as quick as what we can physically write to disk on our primary. So the product team was working through that to improve the performance of this requirement. So that's now changed. We've got greater compression. So they've created a different algorithm, compression algorithm. So we've got greater compression for our send. And for our redo phase, it's gone from serializable to multi-threaded. Therefore, it's able to keep up a whole lot quicker. So my friend Jimmy May, who works for the propulsion labs with SanDisk, he's also a certified master. He's done a lot of testing, performance testing, and comparing the performance gains of 2016 versus 2014. He's just recently published a white paper going through the hardware that they were using and all of these results. So from a CPU utilization, yes, we've got an increase in CPU utilization. However, that means that if we're on newer hardware, higher spec CPUs, we can have less CPUs to do more work. If I've got a server that is averaging 21% CPU utilization, I'm paying for licenses that I'm not using. Okay, if we're sitting at 91%, 100% of the time, we've only got a little bit of overhead left, okay? Using your CPUs is a good thing. Getting the right size is what you want to do. With that, the transactions. Yes, we've got 5 times the CPU utilization. We're pumping through 5 times the amount of transactions. That's a rather large increase in performance. The bytes sent. Now this is in, I think it's in thousands, but it gives you the scale. Huge amount more data being sent through. We can write more, we can send more. Same as with our receive. So with what we're pumping through, we're using more CPU, but we're pumping it through a whole lot more. So with his testing, what he looked at from 2014 SP1, pretty static line of 50 megasecond. Is that okay? Okay, it's all relevant as to what your environment is, how much you're trying to pump through. Now, bearing in mind, these tests were all done the same hardware, so 2 instances on the same hardware, same workloads to do the comparisons. 2014, 50 megasecond. 2016. Okay, 250 meg a second sustained throughput. Now, this is what you will achieve if you go from database mirroring to 2016 standard edition. This is the big performance gain that you will get. If you go from 2014 to 2016, this is where you will get the most bang for buck. So from our 2 data transfer processes, so our asynchronous commit versus our synchronous commit. Our asynchronous, yes, we're pumping through more because asynchronous transactions are actually compressed. Synchronous transactions are compressed, but not to the same magnitude. Okay, so we actually get more throughput with asynchronous. The trade-off: 0 data loss, automatic failover. Potential data loss, manual failover. So it comes down to what your requirements are for your environment. Azure integration, or enhanced Azure integration. So now, in the wizard, when you're going and creating your hybrid configuration, it will now go and confirm and tell you whether your Azure replica meets the criteria, passes, is all okay. Also allows for the listener to be created. Before 2016, if you were doing anything in Azure, you had to do a whole lot of manual stuff via PowerShell to get it all working. This now changes the ballgame, allowing you to start and step up into a hybrid approach. Now, everything that we've spoken about so far has all been about a single availability group which resides on a single Windows Server failover cluster. That's the requirements for us to have. Yes, we spoke about having multi-domain support or no domain support. 2016 also brings to the table a distributed availability group. Now what we've got here is two separate clusters, two separate availability groups, two separate availability group listeners. As per shown here, they're two different locations. They could be in the same location, but we then have an asynchronous data transfer from primary to primary. The benefit of this type of configuration, especially if you are a long distance between your data centers, okay? If we were set up in a 6-node configuration, 1 primary, 5 secondaries, for it to come down here, say we're sending 50 meg a second over the wire. That's by 3. 1, 2, 3. Okay, because it's all different data. So it's 3 streams all having to go across. With your distributed, that's now 1 stream. So 50 meg goes across the wire to Sydney 1. It then transfers down in your secondary. Okay. Potentially a way for doing upgrades. Create a new cluster, transferring the data. You're getting very close to being synchronized. You're then able to do a failover. Your listener will be different, okay, because they're potentially in different domains. If they weren't in the same domain, they're still going to have to be different. So you might have to do some DNS aliasing or CNAME changes to make it work. But this could be a way for you to do a rolling upgrade, reducing the downtime required. So, what have we covered today? We've covered a lot. Okay, we've had a look at our cross-domain support. So whether it be trusted domains, non-trusted domains, or a non-domain Windows Server failover cluster, and the support for availability groups. Our database level failover, health check. If we enable it, it changes the detection from the instance level to the individual database level, allowing it to trigger a failure for all of your databases in that availability group. Our dependencies, so the removal of 32-bit .NET 3.5, we're now a standard edition, so we're no longer required to be an enterprise level feature. Plus also as we mentioned up above, the no domains. Direct seeding, being able to remove the requirement for us to go through the process of doing backup and restore from node 1 to all of your other replicas. As I said, bearing in mind the size of your database, the volume of transactions, the distance you're going to, the pipe that you're sending across. Your distributed AGs, which we just had a look at. Your distributed transaction support. Is that going to make it easier for you to move to availability groups now that that's not fully supported, but does give you a partial support to move forward? The enhanced Azure support, giving us the ability to have more in the wizards to be able to do that work and complete our setup. GMSA support, definitely look at that. Even if it's not just for availability groups, it'll help your other environments. Your uptime operations, that's the big one, especially if your SLAs are very stringent, that you must have X amount of uptime. Any failover, I guess it's how your SLAs are written, okay? If you want to go planned downtime is not part of the SLA, you can save yourself, because when you're doing your maintenance windows, I'm planning to do a failover. That no longer counts. So it depends on how you write your SLAs. The performance improvements. So like we just saw for the log transport, a 5-time improvement. Our round robin readable secondaries. So being able to change the routing list so that we go between however many secondaries we want to utilise the resources on those secondaries without hitting any potential performance impact. SSIS-DB support, allowing us to add the database without having to go and do a lot of things manually beforehand. Standard edition support, is that a big one for everybody? How many people were held off because it was an enterprise level feature? Okay, so start and have a look at this point at the standard edition, okay? It can meet your requirements. The upshot, before we actually went live, so when it was still in CTP, we didn't have a listener. But since we've gone live, it actually included that you could have a listener, which makes it even easier for your failover, which is better than database mirroring. And our improved TDE support, okay? So it asks you when you go and add the database to the availability group, what the encryption is that you're using, what are the passwords for that, to be able to go and set those up for you over on the other environments. So with that, thank you. You've heard it all before. Fill out your evals, okay? It's good for me, it's good for the other speakers. But more importantly, you go in the draw to win a Surface 4 or an Xbox One, okay? So with that, we've got time. I'll open the floor to any and all questions. Question?
Just the requirements on the consuming applications to take advantage of TVs under availability group.
Sorry, so what was your question again?
What are the requirements on the consuming applications to connect to a DB under availability group?
Okay, so the question was, what are the requirements from an application point of view to be able to connect to an availability group? Yes? Yep. Okay, none. Okay, so in your connection string, you're telling it to connect to the availability group listener. The availability group listener is a virtual computer object with an IP address. So instead of where previously you would say connect to server 1, you would now tell it to connect to the availability group listener. As long as if the application drops its connection, so there's an issue at all and we have a failover, as long as the application has the ability to reconnect, it will connect to that listener, okay? The time that it takes to fail over is dependent on, 1, the size of your database, 2, the transactions that were happening at the point in time, okay? Because even though if you're not using readable secondaries, that database is available, but any of the transactions which haven't yet been completed, they have to go through the redo phase to bring that database up and online. So if you've got a very large database with a lot of transactions happening, then your failover time will be different if at a quiet time you don't have a lot happening. Okay, so as long as it can reconnect, that's all you need to have. Question?
You said BTC has some coefficients and cross-DB was one of them on the same instance. How about if you have synonyms created, is it supported?
Is your synonym created for the database in the same instance?
Yeah.
Yeah, so that won't be, so that's at the moment, obviously just with, I don't know the full ins and outs of the DTC support, okay, but anything in the same instance Because of a failover, that's the problem. If it's going to a database on another instance, then it's able to, its connections are able to go and hit that and read and work out where it was at from that distributed transaction. Okay? Because with that rollback, if you and I are in the same instance, okay, and I have a problem, the application, and because I've forced the failover, right, from the application point of view, it's not able to come back and connect to you because you've moved as well, as opposed to you're on that server, I'm on this server, we're talking, I fail over. You haven't moved, so your application is still connecting to you. Okay? That make sense? Okay. Any? Yeah, the timeouts aren't at the availability group level. They're at the clustering level. Okay, so the difference between availability groups and database mirroring, you've got to have the Windows Server failover cluster. Okay, so yes, for your database mirroring, whether you're using synchronous or asynchronous, depending on what your pipe is like, you would have the different timeouts, right, to cater for your particular environment. Same sort of thing happens from a clustering point of view to make sure that the nodes are up and able to talk to each other. Okay, the availability group, no. No. Yes? Say that again.
So when we fail the group,
Yes.
it kills, it terminates all the active process.
Correct.
Is there any better way to do that? Like, what I mean is that I know it's an automatic failover, we can't control it, but in a menu failover, for example, maintenance.
Oh, most definitely. So if you're doing, say you're doing patching,
Yes.
right? So you would do patching in a controlled environment, right? So your normal thing, you would raise your change request, have your outage window for your maintenance, okay? And you would look at having the application stop if you're using asynchronous, right? So you would stop that, make it fail over. The upshot that availability groups give you from a patching point of view, you patch your secondaries first. Production hasn't been touched. Once they're all done, and so this is where your outage, and you control that, and you go, okay, I'm going to have an outage for 10 minutes.
Yeah, I understand. It's
And then,
the business doesn't want to terminate any active process.
I completely understand that the business doesn't want to do anything like that. Unfortunately, as a DBA, you need to lead the business and go, this has to happen. We're having the outage between that. No, if you're doing a planned failover or an automatic failover, it drops the connections, fails over. If there was something that was part way through, then that's going to roll back. Okay, so you only need to use, so from a database mirroring point of view, you're normally doing that specifically if you are going across domains or going between work groups. Sorry? Yeah, so 2 work group machines. So the demo that I showed, right, the non-domain cluster were 2 work group machines, okay? So because of that, that's the only reason in database mirroring that you would have that certificate, because the whole communication is normally at the domain level, right? So I've got a domain account which is on both servers. In the workgroup scenario, we're not in that position. You've got local accounts. There's no way to do it. So you've got to create the certificate on server 1, create the certificate on server 2, export them, create the endpoints on both from the 2 certificates that you've just created, granting your local accounts access to those endpoints which have been created from those certificates. That's the only time that you need to do that with availability groups, okay? Because if you're in a traditional domain setup, you have a domain account, which is so it's the service account of this server, this server, and that account has the permissions, the execute permissions on the endpoints, which is what it's communicating, therefore being able to send the traffic, you receive it, it then goes through the redo process.